This is a presentation that I put together for the Governor's Historical Society about 10 years ago, roughly. I'm Dave Franzen. I'm a professor of soil science and extension soil specialist, mostly soil fertility, but also some soil health things. I work with Neem Kalwar, Abby Wick, Kaylee Gash, Chris Augustine, and others with some soil health topics. So about 10 years ago, the society gave me a call and wanted me to give a presentation on the history of fertilizer application in North Dakota. And I heard the word governor and I said yes, and I hung up the phone and thought, what in the world did I do? I'm going to talk for half hour, 45 minutes on a graph of nitrogen, phosphorus, and potash since 1950 to present. That'll take all of 2 minutes. So I started to think about it, and I started to think about one of the stories that I've heard from older farmers about the buffalo bones, and so I decided to dig in and find out what I needed to know about that. So one of the things that a person needs to understand going into this is that when settlers came to North Dakota, this was a vast prairie, very few trees around. Maybe some of the major streams and rivers in the state had trees alongside of them, but for the most part, very deep prairie soils. A lot of them less than 10,000 years old, east of the Missouri River, and then there were older soils, more fragile soils, West River, but they had very deep topsoils containing relatively high levels of available nitrogen, phosphorus, and potassium. The native calcium, magnesium, micronutrient levels were very high. It was the bank of nutrients that had been gathered by plants in a grazed prairie situation for at least 10,000 years, if not longer. So I know when you go to certain art studios and see those nice little pictures, those paintings of the early pioneers going through the tall grass and with the wagons and everything, occasionally you see a buffalo skull by the side of the trail, but this is really what it looked like. They're just bones everywhere. This is a picture from 1887 from someplace in North Dakota, and this is really common. And I think some people are surprised by that because the general understanding is that the natives used all the parts of the buffalo. And that is all true, that natives used all the parts of the buffalo, but they didn't use all the parts to every buffalo. I mean, how many shoulder bones can a family really use, as a shovel, a scapula, or any other thing? So their bones just scattered out all over the place. Some of these bones in the late 1880s, of course, was from the Great Slaughter to try to get the natives into the reservations, but just naturally, the buffalo would die, the wolves and the coyotes and everything else would eat them. Bones would be left behind. The herds would walk over them and crush some, but you have hundreds of years of bones laying out there in the prairie. So that is kind of what it looked like. So here's some recollections of people that had to deal with this. This is from a young farmhand in Richland County. A.G. Divot from 1882 complained in a letter. He said the bones had to be removed from the path of the plows because the plows, once they hit them, they stopped and just made a mess. But many people made money trading them, selling them to traders. Here's another person, Carl M. Sagan, who farmed between Grafton and Park River. He noted, at first the bones were a nuisance. That was when they first settled between 1880 and 1884. And then a bone market opened up in Park River in 1885, and they received $13 a ton, which is big money back then. So the settlers and others, because not all the land was claimed at that time, would go out in the prairie, gather bones, and then take them to a place where they would be sold, piled up, and then shipped generally to the east to use for various things. This is a picture of a pile of bones near Fort Totten in the 1880s. Here's an advertisement in 1885 from the Grafton News and Times. Notice to farmers, I'll pay cash for buffalo bones, bring them in by the ton or the 100. I'll give 50 pounds of the best twine for 1 ton of buffalo bones this month only, or a $40 sewing machine for 40 tons. I want 5,000 tons this month. Actually, that's kind of cheap compared to other prices I've seen, up to $20 a ton for bones from time to time. Here's some Metis Indians with their two-wheel Red River carts hauling bones near Minnewacan in 1886. Here's some more stories. Sometimes little towns, when they had their centennials here about 30, 40 years ago, would get recollections from people that were still alive at the time, and these are some of them. This is from 1880 in Cullum, North Dakota. First several years were especially hard due to crop failures and low prices. Buffalo bones were picked and hauled to Ellendale in exchange for food and flour. Ellendale was the nearest town at the time and was 42 miles from their farm. This is from the same area. Mr. Kruger broke up about 10 acres of land the first year, but the year was a drought year and he didn't even get his seed back. Mr. Kruger, with nothing else to do after seeding, started picking up buffalo bones, and the bones were sold at Edgeley and Ellendale and received about $12 a ton. He would go out one day and home the next with a wagon load of bones, camping out overnight, and sold about $70 worth of bones during the early part of the summer in 1889, and this helped the Kruger family quite a bit as they had no other income. And another recollection from Lair, North Dakota in 1890, they planted their first flax crop and collected buffalo bones, took them to Ellendale and received $2 a wagon load. So this is just common. This is a part of the way that early settlers were able to survive during the first 2-3 years that they were on the property. Here's a Metis Indian caravan arriving at Devil's Lake at the St. Paul, Manitoba and Minneapolis Railroad Station in 1885, and prices for bones went as high as $20 a ton that year. Each wagon contained about 1,200 pounds of bones. And here's settler wagons with bones arriving in Minot on July 3rd, 1889. And here's a pile of bones in Minot about the same time in 1889. These are loaded up into railroad cars, and so it was all hand labor. Unloaded it, got paid for it, and then people would load the bones into boxcars mostly. This happened all along the northern prairies. This is an illustration in Montana, the one on the top, and down below is one in North Dakota, getting ready to load up into the northern Pacific. In Saskatchewan, you can find references in Saskatchewan, Manitoba. Here's some skulls, the top one piled by a railway siding, and these bone on the bottom is near Ellendale in 1888. Another advertisement, wanted dry buffalo bones. A person seems to be buying everything from scrap iron to bones and hoofs, bone black, fertilizers, etc. So that's what they were sending them to make in St. Louis, Missouri. This is not a fertilizer manufacturer. This is for industrial uses outside of Detroit. In 1892, a pile of buffalo bone skulls. So if that looks familiar, if you've ever seen the movie Revenant, there's a picture from a dream scene after the star, the lead actor, gets mauled by a bear outside of Lemon, South Dakota. He has this dream, and looks pretty familiar, doesn't it? Anyway, so a typical fresh bone meal guaranteed analysis about 3% nitrogen, 15% phosphate, and 3-15-0 in fertilizer vernacular. So after a time, most of the nitrogen is probably going to leach into the soil, but the phosphorus would have been taken up. We don't have any records from North Dakota on how much was shipped out of here, because the Northern Pacific place where these records were stored had a fire and burned. But we have records from Kansas, who had, we think, about similar numbers of bones out in their prairies. They had an earlier trade. That area was settled earlier than North Dakota. So from 1872 to 74, the Santa Fe Railroad and others, they shipped over 3.2 million tons of bones to the east. So we think that about the same number of bones were taken east from here also. And if that was the case, they contained 15% phosphate. Then if you do the math, about 480,000 tons of P2O5 were shipped out of North Dakota east and removed from the ecosystem. And to compare, that's about 2 years of phosphate fertilizer application at today's present rates, which are at historic highs. So that's really interesting. That would take up another 10 minutes of that 45-minute talk. But then I started thinking about probably what I thought might have been at least as much of a phosphate export as buffalo bones, and that was when we lost our topsoil, which in some areas of the state is still ongoing when it gets dry. This is a picture of a dust storm aftermath in McKenzie County back in the 30s. So remember the first slide I showed you was the prairie was this bank of nutrients that had been built up over thousands and thousands of years. Topsoil is very thick. I'll show you some evidence for that in a minute. The people that came here were, for the most part, pretty smart people, and they conducted agriculture the way they were taught to conduct agriculture, the only way that you could conduct agriculture. And this is a farmer or a farm hand on one of the premier tractors of the day with one of the premier implements of the day in the Red River Valley, somewhere between 1910 and 1915 in the Red River Valley. The fields had to be plowed and then worked and then worked and then worked 4, 5, 6 times in order to get them the consistency of flour, because many of you have seen those old planters. They don't have any weight to them. So in order to get the seed at the right depth, you had to have it just as loose as flour. And this is fine from where they came from. I mean, some of these people came from Norway or Germany or anywhere else in Europe and the eastern United States, surrounded by trees, and anywhere where a stiff wind is about 10 miles an hour. And this worked really well. I mean, they had to fight water erosion certainly, but wind erosion is something that most of them didn't ever have to deal with. And of course, the natives that lived out here, how could they tell them anything about the wind? Because to them, this is wrong side up. The roots, the grass roots are up instead of down. So they would never have plowed any soil. The agriculture that was conducted along the Missouri River, for example, the Mandans and other tribes along the Missouri, conducted farming pretty much like the Egyptians did. They waited for the spring flood to recede. It deposited silt along the riverbanks and the floodplains, and then they go in with their sticks and they put the seeds in the ground, their corn and their squash and their beans and sunflowers, whatever else. And that's how they did it. They never turned the field over. So this was the first time. So letters to the east always talked about how windy it was, that people couldn't believe how windy it was all the time. And references of people that were plowing or had plowed always talk about the soil blowing. I mean, the soil always blew. But there really wasn't any concern in anybody for quite some time, even though there were some losses. And then in the late 20s, 28, maybe 29, certainly, the weather started to turn dry. This is corn growing up by Minot, North Dakota, about 1929, 1930. So things started to get dry, crop failures, and again, they're working the ground 5-6 times and getting at the consistency of flour, and the rain didn't come and the wind started to blow. So my colleague, Tom DeSutter, he has an office next to me, teaches and does research at NDSU. He does hospice, volunteer hospice work, you know, as a service to the community. And he was working with one retired farmer and got his family's permission to use this information. So this is Orville Stenerson from Dodge, North Dakota, recollection of the 30s. 1932 was a good year, but 33 was a bad year. 34 was dry with lots of dust. 1935 was a good year with rains. I suppose everything is relative. 1936 was a very bad year, the worst. Lots of dust and grasshoppers. They had 3 loads of hay compared to 20 to 30 in a good year. Dust blackened the sky. They had to turn on oil lamps to see at noon inside. They sold all their livestock. They kept only a dairy cow. They had to use Russian thistle for forage. That's all they had. There wasn't any wheat that year at all. 1937 was better than 36, but still bad. So this made a tremendous impression on this young man at that time. After that slide, I was given a form of this talk up by Gilby, North Dakota, here several years ago, and a retired farmer just stood up in the back of the room, started talking, and this is a part of what he said. He spoke for about 5 or 10 minutes, but these are some ideas that I took away from him. Dust clouds would come out of nowhere and sometimes last for days. In some storms, we lost feet of soil. We stuffed papers and rags into any crack we could find, and the inside of the house was still dusty and hard to see. After the storm, we had to dig out the fences because the stock had walked over them. So these were nasty times. We hear about the Dust Bowl from Texas and Oklahoma and Kansas, but it hit North Dakota just as hard. So by the mid-30s, the USDA had finally figured out that wind erosion was a huge problem in the Great Plains. So that black area in the center of the country, that's us, that's part of us. So here's some photographs from that period of time. This is in Emmons County, just east of Bismarck. That's a fence built on top of a fence. And apparently this is very common. Notice the person's tie. In the mid-30s, the USDA started hearing some feedback from North Dakota on how horrible it was. So they sent out a representative out to the area. His name was Russell. His last name was Russell. And so he took several photographs that are now Library of Congress. This is a photograph of Williston in 1937. There's an old water tower there in the background. Nothing but scrub, and see how the soil is just, you know, those are dunes. Those are little dunes. Here's a horse pasture, quote unquote, during the dust storm near Williston, 1937, another Russell image. This is my personal image, one image that I bought myself. It's a dust storm in Huron, South Dakota, taken November 12th in 1933, and it's 11:55 in the morning, and the street lights are on. You can barely see that vehicle there by the road, but it's as dark as night. This is a huge dust wall coming down onto Watertown, South Dakota in the 30s sometime. This is another daytime picture. This is from Watertown, May 9th, 1934, 3 p.m. And the street lights are on, of course. This is a huge dust storm coming in on Gregory, South Dakota, which is just south of here. Oh, what, 60 miles maybe? In 1934. This is the aftermath of one of those Gregory, South Dakota dust storms. Abandoned farmstead, abandoned machinery, maybe the old family car, maybe the new family car, everything just covered with what used to be topsoil. This is a person, there's actually a video of this person trying to walk against the wind in 1936 on a field. You can just hardly imagine it's a field, but it's a field. And walking into the wind, it's hurricane force. This is the aftermath again. Soil drifting over a hog house in 1935, South Dakota. So the farmers didn't have any money, they didn't have any crops, their fields were ruined. In many places the soil was just destroyed. Some of you have heard of or know or have seen Mick Kerr when he was on TV or listened to him on the farm radio. He grew up in McLeod, North Dakota, which is just on the western edge of the Cheyenne grasslands. Well, the Cheyenne grasslands didn't used to be the Cheyenne grasslands. Every quarter section there was farmed, and Mick told me that he and his dad would go out there sometimes and ride around, and he'd point, you know, over here and say that, you know, Johnson's lived over here and Smith's lived over here, and there was a house in every quarter section, and everybody farmed, and it was a very prosperous area. And then it got dry, and those sensitive sandy soils started to blow, and after several years, everybody moved away. So a lot of these areas were just deserted, that farmers just moved away. So the people that remained, of course, there wasn't anything to feed the stock with. So the government had a program where you bring in a cow or a pig or whatever, horse, and you would get a certain amount of money. I think $10 for a cow, $10 for a steer, maybe $10 for a horse. You drop them off, the government would shoot them, put them in a pit, and most of them had dust pneumonia anyway, so they were going to die one way or the other. So it was a very, very tough time, tough. One of the things that the farmers do a lot now, many of them still think that way, despite educational programs, but they think that after a dust storm, the only soil that moved was what was in the ditch. And some of them joke about trading soil with the neighbor. But they forget that the dust storm is a three-dimensional beast that has height as well as left and right. So here is a clipping from 1934 from the Bismarck Tribune on commenting on a dust storm that happened in late April. So I won't read the whole thing, but it said the most severe of these dust storms occurred on April 21st, 22nd. The velocity of wind was greater on the 21st, but the volume and density of the dust was greater on the 22nd. And the 22nd was remarkable because it was on a Sunday, and travel by both automobile and plane was hazardous and difficult, which is tough because that's the day that most people traveled. And several aviators reported that dust was encountered at all levels up to 14,000 feet. So there's height with these dust storms. So they didn't have satellites back then, but we have satellites now. And so we can look at some of these dust events and we can see how vast they are. This is from the Palouse region of Washington State, which is also a very windy, very eroded area in the United States. And those dust plumes over 100 miles long, and how much of that went in the ditch? How much of that was traded with the neighbors? A little, but most of it blew away. And the same is true with any dust storm that we see in this area also. So the USDA assessed what happened during the 30s in North Dakota. Almost 600,000 acres had really serious erosion. They really needed methods to ensure continued productivity, but 9.1 million acres are so severely eroded that further use for crop and livestock production was economically unfeasible. So we have millions of acres of range in this state, and part of it is because the topsoil blew away and that's all it's good for. And then we have the grasslands, and that used to be farmed and now it's not. So some of that land has probably come back into crops, but a lot of it has just been lost forever for for crop production and sustains marginal livestock production at present. So the USDA made a nice little map here in 1936 about the soil losses during the first part of the 30s. The black indicates areas where moderate wind erosion, which I kind of have to chuckle at that, is 25 to 75% topsoil loss. They've denoted as moderate. And the gray dotted is slight wind erosion, 25% topsoil loss. And then in the southwest part of the state, the oblique is a total of wind and water erosion, 75% topsoil loss. So that's the first half of the 30s, with the other half still to go. So in 1933, a memo to the Secretary of Agriculture said that it was estimated that topsoil losses reduced annual productivity 15 to 25%, and when the soil was fully stripped, fields became unproductive or barren. So here we started with a prairie soil in that grazed environment, and that soil organic matter present at the time was a bank with thousands of years of soil and plant and microorganism activity, and many places that had all disappeared and certainly have been sorely reduced. If you look back at the records, our initial wheat yields in the state were really high, particularly in the eastern part of the state. 40 bushels an acre was cited by historian Hiram Draki that worked at Minnesota State University of Minnesota Moorhead for many years. 30 bushels an acre, 1890 near Jamestown, and near 50 bushels an acre in some years in Walsh County. There's many years where people are going to be happy with yields like that today. And back then they were using marginally adapted varieties. They were using planting equipment that was just one step above what the Egyptians used 3,000 years ago. There wasn't any fertilizer. They didn't have much trouble with weeds back then. The weeds that were imported from Europe didn't have a chance to be established. But it's remarkable that with the crude technologies at the time, they were getting yields that in some years we would still be happy with today. All of that would only be possible if all of those nutrients that were needed for those excellent crops were provided from the soil, because there was no fertilizer applied. Today, if we put in a field of fallow, it's rare, really, that we see over 100 pounds of N per acre coming off our fallow soil, because our soils have been degraded so much. So the soil that blew away, people ask, well, where in the world did it go? Well, it went everywhere. Oceanographers, people that study the oceans and the sediments between them, they core down into the ocean and read it like tree rings, years of deposits, and some of that is dust, some of it is what washes into the ocean to create those deltas, but a lot of it is just dust from wherever. The dust falls everywhere, it just circles the globe. Most of it goes many miles away. Some of the dust storms that were happening in the Great Plains affected small and larger cities. There's records from Chicago, for example, of having to bring out plows to clear the streets after some events. They were finding inches of sediments in Central Park in New York, and so there were at least one group of researchers that during that period of time would go out and take samples of that and then compare it to what was left on the prairies. And some people went out in Central Park and took some samples, and what they found is that the soil that they were taking out of the dust had 19 times more phosphate than what was left in the prairies from where they thought it came from, 10 times more organic matter, 9 times more nitrogen, 45 times more potassium. So all the good stuff ended up somewhere else, and certainly not in the ditch and not in the neighbor's field. Here's another example. This is in kilograms per hectare over on the left, but if you look at the 1.2, 1.4, that's equivalent, if I recall, somewhere around 25 bushels an acre or so. So we're averaging somewhere around 25 bushels an acre back in 1880, 1890, all the way in 1910. And then it started to decline. The weather was still decent, but the topsoil had started to leave. And then in the 30s, when it got dry, of course, the yields went way, way down. During the war years, thank goodness for the war effort, the rains came back and yields increased some, but notice they never came back to where they were in 1900. And they never came back consistently in where they were in 1900 until people started on fertilizer about 1955. So my estimates of topsoil lost, and I think this is conservative, is about 12 inches off the hilltops, 8 inches off the slopes. Average of about 6 inches of topsoil lost in North Dakota from about 30 million acres of cropland, and the total weight of that is around 30 billion tons. It would have been typical then and now to find about a ton of phosphate in acre slice, 6 inches of soil. And if that is the case, then the total phosphate loss during the 30s would have been about 30 million tons, or about 150 years of phosphate application at today's present historically high rates. So after the 30s, it was all fixed. People understood what needed to be done, and they did it, and then there hasn't been any wind. Now, of course not. You know, we've all seen problems. So there were big erosion events in the 40s, particularly in the 50s. There were some in the 70s, and then if people are as old as I am, who can't forget those lovely years of 80, 87 to about 1990, when townships had to use their trucks to take the soil off of streets in many towns and cities in North Dakota with all the wind and all the drought. So here's a picture from a field edge in 1950s in Grand Forks, and that's not snow, that's soil. And we continue to lose erosion and have soils damaged. About 13% of our cropland was damaged in 1977. About 2.1 million acres lost about an inch of soil in 1980. Again, another event in 1982, and it continues and continues and continues. So why aren't growers and landowners more alarmed about continual soil loss? And I think the reason is because they mask the effects with the tillage. They don't have any check for a reference, or they ignore the obvious. There are a lot of, since it's gotten wet, a lot of these stone piles, these rock piles, particularly in the eastern part of the state, but also places around Missouri River have been used as quarries to shore up ditches and culverts and stream banks and things, and so they've kind of disappeared, but there's still plenty of them out there. And if you look real close, you can see that some of these are on pedestals, that they're not the surface of the present soil. They indicate the surface of the soil as it was when the rock piles first were built. And so they kind of stand up on these little things, anywhere from 6 inches, 12 inches, maybe higher than that. But I think this is the big thing that happens. You have simultaneous cultivation and erosion. You have hidden soil losses, and the soil profile just gets narrower. So at the beginning, what we're looking at here is kind of how soil scientists think of the soil. We always think of the soil as if we're standing in a pit. Soil scientists are always in the pits. We're always depressed, right? So anyway, we're looking at it from the side here, and we see what we call horizons. The A horizon in a prairie soil, very, very dark, very black color for the most part. In the western part of the state, that tends to be a little bit more dark brown than black, but still very, very dark, and at the very beginning, pretty thick, 2-3 feet in many cases. And then the B horizon underneath that, that's a zone where the roots and the chemistry have been working, where there's maybe clays that have moved from the surface soils down to the subsoils and increased the clay content there from where it used to be, or there have been lime that's deposited from deeper depths, or salts that have been brought up. Some kind of chemical biological change has taken place. And then the C below that is the original parent material, where there hasn't been a lot of change. Typically pretty low organic matter in that area. Highest organic matter in the A, a little bit less in the B, and then just background noise in the C. So consider you're broken up the prairie for the first time. You have 2 feet of about 7% organic matter soil. You turn it over, it looks really black. Some blows away, but goodness, you know, there's enough there for about 1,000 years, so who cares? And so you're plowing and working, and the wind blows, and the wind blows, and wind blows, and wind blows, and then after about 30, 40 years or something like that, you're looking back in your tractor, and it still looks black to you, but now instead of about 2 feet of black, you've got maybe the depth of the plow black, maybe 8 inches black. Still looks black to you. It's not as deep as it was, but you don't know the difference. And then as it keeps eroding, you start to plow into the B. And instead of 7.5% organic matter soil, all of a sudden you get 6, and then you have 5, and then you have 4, and then you have 3.5. But you're looking back at the tractor after you get done plowing or working the ground, it still looks black to you. And you keep on going and keep on going, and it keeps eroding and keeps eroding, and the B gets blended in with the A, and all of a sudden you're starting to work into the C. And so you have this dark zone that still looks black to you. As far as you know, it's the same black as your great-grandfather had in 1880, but it surely isn't. But to you, you know, there's really no difference. There's no point of reference. And you're working into the C, and then you have, instead of 4%, you have 3.5, and then 3, and then 2.5. And that's how it works. You look in the back of the tractor, it still looks black to you, but it's not. So a graduate student of Dave Hopkins, another colleague of mine, they revisited some soil survey sites that were characterized in 1960 by the SCS, which is now the NRCS. And what they found is this. This is one site in western Walsh County. In 1958, when it was first characterized, the SCS found that the plow layer was about 6 inches thick, that they had 2 B horizons that they characterized. The K means that it has some lime accumulated in them. And it went down to 34 inches. And then the C horizon, the relatively untouched, unadulterated parent material, the depth from the surface to that was about 34 inches. When Dave and Brandon came back in 2014 and ran a transect across the same area to capture the same soil that was characterized in 1958, they found that the distance from the surface to the sea horizon was only 15 inches. So they lost 19 inches of topsoil during that period of time. And the farmer had no idea. Still looked black to them. On the right, you'll see a serious eroded soil near Buffalo, North Dakota, on what's mapped a barn soil, and you can see that abrupt dark and then white, and that means that you're pretty well farming sea horizon there. That the dark up on top is just a blend with a poor memory of what the topsoil used to be right on top of the sea horizon. Sometimes if you get down into the pits and start looking around, you can find some evidence of what the soil used to look like many years ago. These are old worm channels, or sometimes gopher holes. Russian name for them is crotovinas. They fill up with the organic matter from up above. It just kind of washes into it over time. And here's either a wormhole or a root channel from deeper in the soil. And look how black it is compared to the soil up around it. Just there's no comparison between the two. The black in there is probably 6-7%, and the organic matter above it is probably somewhere around 3. So anyway, it's a little bit of a look in the past, the way the soil used to look. here's some additional evidence, and you can find some for yourself. A lot of these old soil surveys are scanned now, and you can find them on the internet. This is one from Divide County in 1900. The Divide soil series was described as having 16 inches of very black topsoil. And Divide soil series, you can find some, of course, in Divide County, but you can also find it West River. There's some mapped West River, and today it doesn't have really any black topsoil. The best you could say is it has a light gray topsoil, and so the losses on those soils are at least a foot because it's not very black anymore. Cass County, that's where Fargo is. A wheatland soil, I've worked on wheatland soils before. The original soil survey in 1903 described it as having 2 feet of topsoil with organic matter of 6.9%. And today it has around 2% organic matter, and it's lost everything. It's lost everything. And then they also describe a Miami loam, which is probably something close to a Bearden, and described it as having 3 feet of 7% organic matter soil. And a Bearden today is most often about 6 inches of 4%. So the probable loss on these Bearden soils is probably 2.5 feet. And the Fargo soil series in 1903 was described as having 2 feet of very black topsoil, and today it's around 6 inches of 4.5 to 5.5% topsoil. So the losses on these soils have just been incredible. So the topsoil again contains about a ton of phosphate, and North Dakota's probably lost an additional 6 inches of topsoil from 10 to 20 million acres of cropped acres since 1940. And if that's the case, and I think it's true and probably conservative, we've lost another 12.5 million tons of phosphate and 40 million tons of nitrogen, and that's equivalent of 75 years of nitrogen and phosphate application that farmers apply today at present rates. And in many areas of the state, it still happens. If you want to see a dust storm come the first time it dries out this spring in the Red River Valley, especially the Northern Valley, and just kind of drive around, and hopefully in an old car, because your other car will be pitted with all the sand and the soil that's blowing around. But this is very common. So as soon as the soil dries out, because there's very few fields in this area that are no-till, strip-till. More of them have cover crops than they used to, but still it's a very heavily cultivated area. This is the aftermath of a late 90s dust storm in the valley. That's the aftermath soil filling the ditch several feet in depth. These are other pictures of soil filling the ditches, and then look at that cloud above it. I mean, all that fine stuff, all that good stuff is just blowing away, probably hundreds of miles. Certainly not in the neighbors. The coarse stuff gets in the ditch. The really good fine stuff, that's what goes away. So there was a lot of work about roughing up the soil, but that only lasts for about one dust storm, and then it's all gone, and then you got to deal with the aftermath. So most of the time we get more than one event a season. People laugh at snert, but it's not funny. It's just an indication that things are not the way they're supposed to be. And soil in the ditch is supposed to be white, and if it's not, things in the field need to be fixed. So one of the crops that people are loath to use no-till and strip-till on is sugar beets. They're just scared to death that we don't have the equipment to go through residue with these things. But that's not true. This is in the 1930s. We have, you can go to farm shows, and for any kind of field situation, you can find farm machinery that can go through and plant in a reasonable manner through any kind of residue that you can think of. People try to use some residue and use some what they call conservation tillage, but just slows the inevitable. You're still going to lose soil. Look along the tree line to the background, and you can see dust blowing across the field. Most of our tree belts in the state have reached maturity and are on the other side and starting to die off. Some people think it's spray, but I think in most cases the trees don't last forever. These aren't sequoias. They don't last 2,000 years. A normal lifespan of a cottonwood's probably 50, 60 years, something like that. Some of these other trees that are grown into the shelter belts, the ashes and others, about 50, 60 years, and they start to go away. So this is just reasonable. They need to be renovated and not just torn out and forgot about. They're there for a reason. They really helped before there was no-till. Now the people in the West are in no-till, and the tree rows aren't quite so important anymore, but it still slows the wind quite a little bit. It's a picture of sugar beets growing in no-till out in Montana. Of course, they don't have the moisture problems that we do here in the East, so maybe no-till is not the right thing to do, but certainly something like strip-till certainly could be, and has been shown to be very effective. This is some strip-till corn growing down in Rutland, and I took 250 bushel corn off of these plots here a few years ago. Extremely productive, very long-term no-till over 40 years, tiled for 20 years, high clay soils just like there are in the valley, strip-till corn, 250 bushels. It's hard to have any conventional field that would beat a farm like this. So my campus plots, it's no-till beets, strip-till beets. Never found a difference in yield between the conventional till and the strip. So strip till beets again. Strip till is good for row crops and particularly those that are warm season, but even sugar beets works pretty well. And if nothing else, at least put a cover crop in there. I know this last year, we're speaking here in spring of 2020, that fall was not really conducive to plant a cover crop, but if that was put into a person's schedule, in most years you'll be able to put some in, and that at least offers some protection from wind erosion, even water erosion in most years. So to kind of wrap things up, despite historic high rates of fertilizer nutrients, levels of phosphate on many North Dakota farms are still low, and we probably have at least 200 years of no soil loss and continued phosphate application to catch up to where we were in 1890. The soil loss helps answer these questions, because I get these questions from time to time from people that are in conventional tillage. Why don't my soil phosphate values improve? Well, because they seem to blow away every year. Why is my soil pH increasing? It's because the subsoil in most of our soils is very high in lime and pH, and you keep digging up more subsoil and putting it, mixing it with the topsoil. So of course your pH is increasing. And why do I have more soil crusting? It's because your organic matter is very low and your good stuff blows away. And with lower organic matter, you have a greater problem with soil crusting, and you're mixing in your sea horizon, which has hardly any structure to it at all, and with your topsoil. So all of those questions are answered because your soil is blowing away. The only remedy for continued soil degradation is no-till or modified no-till, such as strip-till. So to summarize, North Dakota has a long history of phosphate export, first on purpose with the buffalo bones, but the second as an unintended consequence. Soil fertility is intimately related to soil conservation, and the only way to restore soils is through a long-term no-till commitment. So thank you for viewing this presentation. This is my contact information below. You're welcome to contact me at any time. Be happy to talk with you or visit with you over an electronic device. Thank you.